Hello, welcome to our mini project. So our simulation is about simple RLC circuit in MATLAB. Our group consists of Fasran, Prakash, Annalise, Hafiz, and Jack. So let's get started from introduction part.
For introduction, RLC circuits in the domain of industrial physics is crucial for understanding the intricate interplay of passive components in electronic systems. By employing MATLAB as a computational tools, we can systematically explore the dynamic behavior of RLC circuits, including transition responses, frequency characteristics, and impedance profiles. This comprehensive analysis enables us to unravel the complexities of RLC circuits and leverage their potential for innovation and problem solving in industrial applications. Transition responses. By simulating the response of RLC circuits to various input signals, we can gain insight into the system's stability, damping, and oscillatory behavior. Frequency characteristics. By calculating the natural frequency, damping ratio, and impedance profiles, we can determine the system overall response to different frequency input. Impedance profile. By analyzing the impedance profile of RLC circuits, we can determine the system overall response to different frequency input and identify potential areas of improvement or optimizations. System optimization. By leveraging the insight gains from the analysis of RLC circuits, we can optimize the system's performance by adjusting the value of the passive components or the circuit topology itself.
So next, let's talk about the objective of this mini project. So the first one is to develop MATLAB script for RLC circuit, transient response accounting for varying resistance, inductors, and capacitance. And then to implement advanced technique for frequency response analysis, capturing amplitude characteristic and resonance. The next one, explore RLC circuit in impedance characteristic, including real and imaginary component, for insight to the diverse operating condition. And last but not least, to present stimulation result clearly, utilizing suitable visualization for easy interpretation by industrial physicists and engineers. Now for the problem statement. In industrial physics, accurately simulating and understanding the behavior of RLC, which is the resistor, inductor, and capacitor circuit, is essential for various applications. However, this poses a significant challenge due to the complexity of RLC circuit, where the problem at hand is to develop a MATLAB script capable of simulating the behavior of simple RLC and analyzing the transient response, frequency response, and impedance characteristic. This project will aim to address this challenge and demonstrate the practical application MATLAB in industrial physics research and practice.
Flowchart of this program start with the start, define the circuit parameter, define the step input, and have a three calculation for impedance characteristic, frequency response. But in transient response, they have create a differential equation by using ODE solver and plot it based on the subject. First, the impedance characteristic, transient response, and frequency response, and lastly, print the GUI and N. The function in the simulation in transient response function, they create by to visualize the transient response of RLC circuit by take two input argument x1 and y matrix 1. The plot line differentiate by color red and blue. For red for current, blue for voltage. This figure include a title, x-axis label, y-axis label, current and voltage, and a legend. Secondly, the frequency response. This visualize the frequency response of the RLC circuit. It take two input argument also, x1 and Y1 for frequency data and output voltage magnitude. This figure using a log scale to plot the data showing the relationship between frequency and output voltage magnitude. This figure include a title, x-axis label, y-axis label, and grid line. Lastly, the function for impedance characteristic. This function visualize the impedance characteristic of the RLC circuit. It takes two input also, x1 for a frequency data, y matrix 1 for a matrix of y data, real and imaginary part of impedance. This figure using a logarithm scale for x-axis and plot both the real and imaginary part of impedance on the same axis. The plot line using red for real and blue for imaginary. This figure include a title, x-axis label, xy axis label, and a legend. Thank you.
Moving on to the result of the stimulation, let's take a closer look at each part of the script and understand how it contributes to our analysis. So for the first one, the transient response. The first part, our script focuses on the transient response of the RLC circuit. We define the circuit parameters including resistance, inductance, and capacitance, and then we set the initial condition for current and voltage. Using the MATLAB ODE solver, we solve the differential equation that describe the circuit behavior over time. So the resulting plot shows how the current and voltage change in response to a step input voltage. For the frequency response, we generate the range of frequency and calculate the output voltage magnitude using MATLAB. By plotting the output voltage magnitude against the frequency, we can observe how the circuit responds to different input frequencies. This helps us to understand the circuit filtering characteristics and its ability to pass or attenuate a certain frequency component. And finally, let's explore the impedance characteristic of RLC circuits. For this one, we calculate the impedance of the circuit across the frequency spectrum and plot the real and imaginary part of the impedance. This plot will give us insight into the resistive and reactive component of the circuit as well as the resonant frequency. So our MATLAB script provide the comprehensive analysis of RLC behavior. By stimulating the transient response, frequency response, impedance, and characteristic, we gain the valuable insights into how circuit operates under the different conditions.
So now I'm going to explain about the Simulink, which is we use the MATLAB to construct the RLC circuit in the Simulink. So as shown in the figure above, we use the voltage source, emitter, power GUI, resistor, inductance, capacitor, 3 voltmeters, and 4 scopes, and finally a MOX. So voltage source is modified to the desired voltage we needed, and the resistor, inductance, and capacitors instruments are modified whether we want resistor, inductance, or capacitor, and we set the desired value we needed. For the voltmeter, we connected the first voltmeter between the resistor and second between the inductance and finally the third between the capacitor. And the output of voltmeter are connected to the MOX, and the output of the MOX is connected to the scope 4. The first scope, second scope, and third scope are connected to the emitter, and the first scope is connected to the first voltmeter, which is connected to resistor, and the second scope is connected to the second voltmeter, which is connected to the inductance, and finally the third scope is connected to the third voltmeter, which is connected to the capacitor. So this is the Simulink of the RLC circuit, which is constructed using the MATLAB. So as you can see, here is the result for graphical user interface, which is GUI for RLC circuit. So here we can see the coding of the RLC GUI circuit, and another figure is show the result in simulation of GUI for the RLC circuit. So from the result you can see there are four graphs. So the first is board diagram, which is for gain and phase, and the second is for output waveform, which will show the voltage and current. So for the circuit characteristics, there are resistance, which is stands as L, inductance, which is L, and capacitance, which is C. So you can adjust the value for the value you wanted, and there is the units for each resistance, inductance, and capacitor. For resistance, the value are milliohm, ohms, kilo ohms, and mega ohms. For inductance, the values are in microhenry, millihenry, and nanohenry. However, for capacitance, the values are in microfarad, nanofarad, and picofarad. And also you can see the damping factor. And in the circuit and signal types, you can choose between pulse wave, signal, sine wave, and triangle wave. And there is a properties for angular resonance, which is the value is radian over seconds, and phase margin. So that's all for graphical user interface for RLC circuit.
To sum up, our study on RLC circuits using MATLAB help us understand how this electronic setups works. We look at how resistors, inductors, and capacitors interact, focusing on quick responses and frequency patterns. This knowledge is important for engineers dealing with electronic systems. We use MATLAB for its practical abilities in making complex circuits easier to understand. Our clear visual presentations of simulation results aim to help professionals in the field. This work showcases the teamwork of theory and practice, aiming for innovation and excellence in industrial physics. In a nutshell, our exploration demystifies RLC circuits, contributing to a better understanding of these electronic systems. Thank you.
That's all from us. Sorry for the inconvenience and imperfection of our group. Thank you for watching.